Now also I've changed the network. Can you hear me now? Am I audible?
Yes,
Yes. So Mary, yesterday we were studying the Rutherford model. So what we have learned, we have learned that Rutherford did an experiment. What did he do? Basically, Rutherford's experiment is also known as alpha particle scattering experiment. What did he do? He took a radioactive source from which he imparted, he bombarded alpha particles on where? On a gold plate. So why did he take the gold plate? Because gold is a metal and it can easily be drawn into very thin sheets. Okay? So he took a gold plate and he bombarded alpha particles. Okay. So, after bombarding alpha particles, uh, there were three observations. Take what were those three observations, and on the basis of those three observations, uh, conclusions, some conclusions were made. So first, let us revise ki what were those three observations. The first observation which Rutherford did was that most of the alpha particles, if for example if they were following this path, for example this was the source and this was the plate, okay, and this is the screen. So most of the alpha particles were undeflected, okay, they followed the path which they were following. ठीक, they did not go anywhere. अगर उन्हें यहाँ hit करना था तो they hit that point only. ठीक. Also, the second observation was that only a small fraction of alpha particles was deflected by a small angle. Small fraction means some of them were deflected, and they were only deflected by a small angle. Okay, some of the alpha particles, which I am representing by green, they deflected. Okay, they deflected. मतलब they did not follow the original path. ठीक है. The third observation was that only a few. And what did only a few means? If I'm talking about numbers, so if I have taken 20,000 alpha particles, then in 20,000, only one of the alpha particle retraced its path. It means जिस path पे वो आया था, it got back to that path. Okay, so these were the three observations which Rutherford made on his experiment. Acha, what did the conclusion he made? So after doing this experiment, he made several conclusions. Let us see the conclusion. These were the observations. See, now let us see the conclusions. So what were the conclusion? The first conclusion that he made was most of the space in the atom is empty. Why? Because most of the alpha particle pass undeflected. Achha, what was the charge on alpha particle? Alpha particle, I told you that alpha particle is helium plus. Helium पे अगर plus charge लगा दें, उसका एक electron निकाल दें, so it is known as alpha particle. So why did most of the alpha particle remain undeflected? Because अगर फॉर एग्जाम्पल अगर हम इसको टैली करें, इफ वी टैली दिस मॉडल विद थॉमसन्स मॉडल, तो थॉमसन ने क्या कहा था कि पॉजिटिव चार्ज इज uniformly distributed all over the atom, right? So if that was true, so many of the alpha particles should be deflected, right? Because positive will repel each other, so most of the alpha particles should be deflected, but only some of the alpha particle deflected. तो इससे क्या conclusion निकला? इससे conclusion निकला कि most of the space of atom is empty. Why? Because no repulsion was there. Because of no repulsion, he made this conclusion that most of the atom was empty. ठीक? Okay? Since see, we were talking about alpha particle that is positive charge, and we are bombarding that alpha particle on a metal plate, तो उसमें भी atoms होंगे, so atom उसमें भी होंगे, और we are taking alpha particle that is also atom. अगर इस this gold foil is an atom and the charge is uniformly distributed, so alpha, most of the alpha particles should have deflected, but only a few deflected. ठीक, तो पहला रिलेशन ये हो गया. दूसरा जो हमने ऑब्जर्वेशन देखा था, उससे सेकंड कंक्लूजन वाज मेड कि only a few positively charged alpha particle was deflected. Why was they deflected? This deflection was due to the repulsive force due to the positive charge in the gold foil. ठीक है, तो the second observation, the second conclusion that was that कि few alpha particle का deflection हुआ था was due to the repulsive force of the positive charge in the atom. ठीक, so if only few of the alpha particle deflected, तो उसका मतलब I have already told you कि इसका मतलब the charge is not distributed. ठीक, अच्छा, are these two conclusions clear?
Yes, ma'am.
Okay.
And this
Now
conclusion are the of Rutherford's model.
these are the conclusions of Rutherford model, because we are talking about the alpha particle scattering experiment, or alpha particle scattering experiment was of Rutherford only. ठीक है?
Okay.
Yes. Now the third observation was that Rutherford did some calculations, and with that calculation, he said that if the radius of atom is 10 raised to the power 10 meter, then only a small amount is occupied by the nucleus. Nucleus मतलब positive charge. ठीक है, मतलब if it is 10 raised to the power minus 10, so only 10 raised to the power minus 15 meter is occupied by the uh, nucleus. Nucleus मतलब the positive charge. For example, if you want to see this value, so if I am saying this is a cricket field, so cricket field में if I put a ball, cricket field में I put a cricket ball, so the cricket field is the atom and the cricket ball is the nucleus. ठीक है, so by the conclusion he said that कि if the radius of the atom is 10 raised to the power minus 10, only a small portion is occupied by the nucleus. ठीक, so these were the conclusion which he made on his observation. ठीक है, अच्छा, now by these observations, he proposed a nuclear model. And what were the postulates of that model? He said that the positive charge of the atom is only concentrated in a small region. ठीक है? तो अगर एक बड़ी सी क्रिकेट फील्ड में I put a cricket ball in the middle, so that cricket ball is the positive charge. So the positive charge is constricted in the small region of the atom. ठीक है, and अभी in the previous class we have seen कि electron has very negligible mass. All the mass, जो भी mass atom का होता है, that is contributed by protons and nucleons only, protons and neutrons only, right? So he said the mass and the positive charge is concentrated only into the small portion. ठीक है, and that small portion he called nucleus. The nucleus term भी Rutherford ने ही दिया था. He said that the mass of the atom and the charge of the atom, the positive charge of the atom is constrained to a very small portion in the nucleus. तो पहला postulate जो उन्होंने अपने मॉडल में दिया, that was this. ठीक, अच्छा, next postulate what did he say? He said the nucleus is surrounded by electrons that move around the nucleus with a very high speed in a circular orbit. उसके बाद what he said that nucleus के around there are orbits. Orbits क्या होंगी? जैसे planets के orbit होते हैं. So he said that nucleus के around there are orbits, and the electron, जिसको हम negative charge कह रहे हैं, they are moving around the nucleus in circular path. ठीक, अगर if we compare our atom, this is atom को अगर हम solar system से compare करें, so सोलर सिस्टम से अगर हम कंपेयर करें तो एटम में इफ वी टॉक अबाउट न्यूक्लियस, so nucleus is the sun and electrons are the planets. ठीक है, so he in his nuclear model he said this second postulate उन्होंने ये कहा. First postulate he said that all the charge and all the mass are concentrated, all the positive charge and all the mass is restricted to a small region. Second he said that small region, around that small region there are orbits on which the electron are moving in a circular path. ठीक, अच्छा. Now third postulate what did he say? He said कि these electrons, ये जो electrons हैं ये अपनी पोजीशन पे क्यों है? ड्यू टू द इलेक्ट्रोस्टैटिक फोर्स. कि न्यूक्लियस में वी हैव पॉजिटिव चार्ज एंड इलेक्ट्रॉन्स में वी हैव नेगेटिव चार्ज, सो देयर इज एन इलेक्ट्रोस्टैटिक फोर्स व्हिच आर कीपिंग दीज इलेक्ट्रॉन ऑन इट्स पाथ. ठीक, तो इनके इन रदरफोर्ड atomic model we had three postulates. First one is about nucleus, second one is about orbit, and third one is about the force on the force which are keeping together the electrons and the nucleus. ठीक,
Yes, ma'am.
so that was all about Rutherford model. अभी we'll see कि why was this not accepted, why did we need another model. उससे पहले we'll learn about atomic masses and atomic number. So before moving to atomic mass and atomic number, let me tell you, we have learned three subatomic particles, right? Electrons, protons, and neutrons. ठीक है? Electrons have negative charge, protons have positive charge, and neutrons have zero charge. ठीक है?
Yes.
Okay. Now let us see what is the atomic number, what of these subatomic particle constitute the atomic number, and what of these subatomic particle constitute the mass number. Let us see. Now as we already know that the charge on proton is equal to the charge on electron, but only the sign is different. Okay? Now the number of protons in the nucleus is equal to the atomic number. Okay? So whatever will be the number of protons, that will be the atomic number of elements. See? So what did I say? I said if you are saying if you take any element and if you have to see its atomic number, just count the number of protons. ठीक है? अच्छा. Now someone can say कि we know कि किसी भी neutral atom में, if you're talking about a neutral atom, so in neutral atom, the number of positive charge is equal to the number of negative charge. तभी तो that atom is neutral. अगर we have 4 positive and we have 4 negative, they'll cancel out each other and the net charge will be 0. So why are we not saying कि atomic number is contributed by electrons? Because electron can an element can easily lose the electron and it can easily gain electron. इसीलिए if we are talking about atomic number, so we will talk about protons. ठीक. Now if I'm saying कि hydrogen का atomic number is 1, so it means it has 1 proton. If I'm saying sodium का atomic number is 11, it means it has 11 protons. ठीक. अच्छा. And I have already told you to keep any element neutral, we have the number of electrons equal to the number of protons. ठीक है? अच्छा. So if I have to write the atomic number which is represented by Z, so I can say Z is equals to the number of proton in nucleus of an atom. Or I can say it can be also equal to number of electron in neutral atom. अगर if you are talking about electron, so it is necessary that you specify that you are talking about a neutral atom. ठीक है? Okay. Now, so हमने बात कर ली एटॉमिक नंबर की. So are we clear with atomic numbers? There also एक thing आती है, एक word आता है न्यूक्लियॉन्स. तो न्यूक्लियॉन्स क्या होते हैं? न्यूक्लियॉन्स आर प्रोटॉन plus neutron. If we sum up the number of protons and the number of neutrons, they will be called as nucleons. And the number of nucleons constitute to the atomic mass. ठीक है? Clear? What is atomic number and what are atomic masses? Let us see some example of this. ठीक. अच्छा, उससे पहले let me write the formula for atomic number, mass number. Mass number या atomic number is represented by A, and इसका formula is number of protons plus number of neutrons. अच्छा, why is mass contributed by both the thing, but the uh, atomic number is constituted by only neutrons? क्योंकि 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 प्रोटॉन न्यूट्रॉन्स में कोई चार्ज नहीं होता है. Okay, so neutron doesn't have charge, so it does not constitute to the atomic number. But neutron has a mass. इसके पास मास होता है, इसीलिए it is constituting to the atomic mass. ठीक. Okay. Yes. Now, I'll give you some examples ki how to find this kind of question you'll come across. Ki how will you find the atomic number and atomic mass, या number of protons. You will be given the atomic number and you would have to find the number of protons and number of electrons. ठीक है? Let me show you. For example, let us take an example of calcium. ठीक है? Calcium has the atomic mass 40 and atomic number 20. ठीक है? So if I ask what is the number of proton, so can I say in number of proton in this calcium is 20, right? Because its atomic number is 20. And if I ask what is the number of neutron, so I can easily say that it will also be 20. Why? Because mass number is 40 and mass number equals to protons plus neutrons, which is 40, and protons we have already seen that it is 20. So neutrons I can easily say that it will be 21, right?
The atomic mass, that's
Okay.
in calcium.
This is atomic mass and this is atomic number.
Okay.
So atomic number is constituted by proton only, and atomic mass is constituted by proton and neutrons both. So if I know the number of protons, I can easily find out the number of neutrons if I know the atomic mass. See, for example, if I'm saying that 1 plus 1 makes 2, ठीक है? या for example, if I'm saying मेरे पास दो चीजें हैं and दोनों जोड़ के 2 बना रहे हैं, ठीक है? और if I know कि the first number is 1, so I can easily find out the other number. Right. So ऐसे ही if I'm saying mass number is 40 and I already know that number of neutrons is the number of protons is 20, so I can easily find out the number of neutrons, right?
Yes.
Also if I'm saying that this calcium is a neutral atom, इस पे कोई charge नहीं है, तो अगर इस पे कोई charge नहीं है, so number of electrons will also be 20. Why? क्योंकि protons और electrons एक दूसरे को cancel कर रहे होंगे, एक दूसरे को effect को, तभी तो the atom, the element is neutral, right?
Yes.
Okay. So are we clear with the atomic number, atomic mass?
Yes, ma'am.
ठीक है. Let's see if we have any question. Okay, we have a question, but before that question, there comes the concept of isobars and isotopes. Isobar and isotope. Acha, before telling you the isobars and
Ma'am, in
isotopes,
calcium, the number of
yes.
electron is also 20.
Yes, and number of electrons is also 20. Why? If the protons are 20 and this calcium is a neutral element, right? Calcium is neutral, no charge is there. So if there are 20 positive charge and the net charge is 0, it is necessary that negative charge should be 20 only in order to get the net charge 0, right?
Yes, ma'am. So the number of neutrons should be 0
Why should be number of neutrons 0?
because proton and electrons are cancelling each other.
Okay, they are cancelling each other. Proton and neutrons are two. Proton is a different thing, electron is a different thing, and neutron is a different thing. Neutron doesn't have any charge, but it has a mass. For example, if I'm saying ki, how do I explain you that? For example, if I'm saying that I have a box, ठीक है, मेरे पास एक box है, and in this box I have 1, 2, 3, 4 positive charge, 1, 2, 3, 4 negative charge. ठीक है. अच्छा, now I'm also saying that इस charge का जो mass है that is 8. Sorry, this box का जो mass है that is 8 and the charge on this box is 0. See, electron के पास mass तो होता नहीं है, it is approximately equal to 0. And if I'm saying कि 4 है and इसका mass 1 है, the mass of the proton is 1, it means there is something else. इसका मतलब इसमें 4 चीजें और present हैं, that's why its mass is 8, right? So what are those 4 things? That 4 things are neutrons. Neutrons, protons and electrons are 3 different things. Okay, they exist independently, they are not dependent on each other. तीनों independently exist करते हैं. बस इन अ न्यूट्रल एटम ऐसा होता है कि सिंस पॉजिटिव चार्ज और नेगेटिव चार्ज इक्वल होते हैं तो दोनों एक दूसरे को एक दूसरे के इफेक्ट को कैंसिल करते हैं. तो दोनों एक दूसरे को खत्म नहीं करते हैं, वो चीज वही रहती है, बस उनका इफेक्ट महसूस नहीं होता है. ठीक है.
Okay.
फॉर एग्जाम्पल, अगर अगर इफ आई एम सेइंग कि एक आयरन नेल है मेरे पास, ठीक, एंड मैंने यहाँ एक मैग्नेट रख दिया. नाउ दिस मैग्नेट विल अट्रैक्ट दिस आयरन नेल टुवर्ड्स इटसेल्फ. अब इस साइड भी मैंने एक मैग्नेट रख दिया सेम डिस्टेंस पे और सेम वैल्यू का. सो ये आयरन भी अपनी, ये मैग्नेट भी आयरन नेल को अपनी तरफ अट्रैक्ट करेगा. अब क्योंकि दोनों इक्वल हैं और इक्वल डिस्टेंस पे रखे हैं तो ये नेल अपनी जगह से हिलेगी नहीं. वाई? क्योंकि उसके दोनों तरफ से इक्वल फोर्स लग रहा है. बट लेकिन मैग्नेट, नेल और दूसरा मैग्नेट वो एग्जिस्ट तो कर रहे हैं ना, भले इस नेल पे कोई इफेक्ट नहीं लग रहा है, बट ऑल द 3 थिंग्स आर देयर ऑन द टेबल, राइट? तो यही हो रहा है इस एलिमेंट पे, यही हो रहा है कि इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन तीनों एग्जिस्ट कर रहे हैं, बट इलेक्ट्रॉन और प्रोटॉन का इफेक्ट कैंसिल हो जा रहा है, इसलिए वी आर नॉट एबल टू सी द चार्ज.
Okay.
Clear? Very clear? Any confusion?
No.
Okay. Now let us move to isobar and isotopes. Before moving to isobar and isotope, let me tell you कि how to represent any element. कोई भी element का atomic number और mass number हम लोग represent कैसे करते हैं. If I am saying कि I have any element X, ठीक है, एक element है मेरे पास X. X could be any element from the periodic table. 114 elements में X could be any element. Now its atomic mass, उसका atomic mass is A and its atomic number is Z. ठीक, so how will I say? तो atomic mass जो है it is written on the superscript and atomic number is written on the subscript. इसीलिए when I wrote calcium, तो I wrote 40 on the upper side and 20 on the lower side. Okay, so if I write sodium, so I'll write like this: 23 उसका mass number and 11 उसका atomic number. ठीक है?
Yes.
So this is the proper representation of any element in with its atomic number, atomic mass. अच्छा. Now coming to isobar and isotope. देखो, we have two things: isotopes and isobars. तो isobar वो होंगे their atomic number that will be different. ठीक है? But atomic mass will be same. ठीक?
Yes.
So, for example, if I have nitrogen, इसका atomic number is 7 and its atomic mass is 4, and I have an oxygen. Now, एक oxygen ऐसा भी exist करता है जिसका atomic number is 14, not 16. So now this atomic number, atomic mass 14 वाला oxygen and atomic mass 14 वाला nitrogen, they are isobars. ठीक है? Why? Because their atomic number is different and their atomic masses are same. ठीक है? और
Yes.
आइसोटोप में उल्टा हो जाएगा. Their atomic masses will be same. Sorry. आइसोटोप्स में क्या होता है? आइसोटोप कार्बन 12. हाँ. Their atomic number will be same and their atomic masses will be different. ठीक है? So atomic number will be same. For example, I am saying carbon. दो कार्बन है, दोनों का एटॉमिक नंबर इज 6, बट एक का एटॉमिक नंबर इज 12, एक का एटॉमिक मास इज 12 एंड एक का एटॉमिक मास इज 13. ठीक है? तो दीज आर आइसोटोप्स. सो इफ Z इज सेम, ठीक है, थोड़ा सा कॉम्प्लेक्स में आते हैं. इफ Z is same, Z मतलब atomic number is same, so they are isobar. ठीक है? And if A is same, A क्या हो गया? Z क्या हो गया? Atomic number. So they are isotopes. If atomic number is same, they are isotope. And A क्या हो गया? Mass number. If A is same, then they are isobar. Clear?
Yes.
So let us see some examples of isotopes and isobars. Isotope example, nitrogen and carbon I gave you. Now let us see that isotope example. Isotope example, we have 3 isotopes of hydrogen. Their atomic masses are 1, 2 and 3. ठीक है? One को we call protium. Proton यहीं से आया था, ठीक है? Because the smallest positive charge that was discovered was from the hydrogen, इसीलिए उसका नाम proton कहा गया था. That was from hydrogen, protium. The other one we have deuterium. Its atomic mass is 2, and then we have tritium. Its atomic mass is 3. Protium, deuterium and tritium. अच्छा, इसको H ना कह के we write like this: deuterium and tritium. ठीक है? तो हाइड्रोजन का बहुत फेमस एग्जांपल है, यू मस्ट लर्न उनके नेम: प्रोटियम, ड्यूटेरियम एंड ट्राइटियम. देन वी हैव कार्बन के आइसोटोप्स, दैट इज कार्बन 12, कार्बन 13 and carbon 14. If you remember, we have learned average atomic mass, right? तो average atomic mass हमने जब पढ़ा था तो हमने कार्बन का एग्जांपल लेके पढ़ा था. ठीक है? These are the isotopes of carbon.
Yes.
Okay. Now, beside this, we also have an isotopes of chlorine. इसका atomic number 35 और atomic mass 35 and 37 and atomic number is 17 for both. ठीक है? अच्छा, Now, why are we studying isotopes and isobar? Because the chemical properties of the atom are controlled by the number of electrons, which is determined by the number of protons. ठीक है? Chemical properties कैसे is controlled by the number of electrons? अभी we'll see कि electrons can be easily be removed and added in the atom. ठीक है? So if electron can easily be removed, they will be metals, and if electron can easily be added to any atom, then they will be non-metals. ठीक है? अगर कोई atom can easily gain positive charge, तो उसको हम metals कहते हैं generally, and if it can easily gain negative charge, तो उसको हम लोग generally non-metals कहते हैं. ठीक है? कैसे कहते हैं, क्या कहते हैं, अभी भी study. Our proton and electron protons and electrons collectively define the chemical properties. Neutrons का chemical properties पे कोई effect नहीं होता है. It only decides the atomic number. ठीक है?
Yes.
अच्छा. Since chemical properties are determined by the number of electrons, which is dependent on the number of protons, so जो isotopes जो होंगे उसमें number of protons तो equal होंगे, right? क्योंकि atomic number सबका same है. So isotopes will have same chemical properties. Why? Because their number of protons are equal, and if their number of protons are equal, so number of electrons will be equal, and the chemical properties is controlled by electrons only. Okay?
Yes, ma'am.
Are we clear up to here? Any problem?
No, ma'am.
Okay. Now I'm giving you a question. Solve that question. Okay. If I give you, for example, I'm not giving the question from the uh, book, I'm giving you any other example. Let me see what example I can give you. Okay, I'm giving you an element. Fluorine, जिसका atomic number is 17 and atomic mass is 35. Tell me the number of protons, number of neutrons, number of electrons. Also tell me the number of nucleons.
Number of protons is 7
Number of
and neutron is
protons
18.
17. The number of neutrons is
18.
very good.
Electron is
And what was
17
very
and
good?
neutrons is 35.
Very good. So you have understood the concept of atomic number and atomic mass. Okay. Now let me explain you something. Is this there only या किसी दूसरे chapter में ये concept? Let me see. Okay, yeah, it's not in any other chapter or anything, but I'm explaining you this as extra. See, अभी what did we study? अभी we have studied कि जो protons होते हैं, they are deep inside the nucleus, right? And अच्छा, I'm explaining you कि how any element gains positive charge or it gains negative charge. ठीक है? I'm explaining you that कि किसी भी element पे किसी भी atom पे charge कैसे आता है. ठीक? Stay very careful. I'm saying that I have any element and उसपे there is, for example, let us say कोई है उसमें I have four protons and I have 4 neutrons. ठीक है? And what I have to do is I have to make this element positive. ठीक है? So इस element को positive बनाने के लिए I have 2 ways. What can I do? I can either increase the positive charge, right? I can increase the positive charge. If I'll increase the positive charge, so this positive charge was cancelled by this was cancelled by this electron. I'm giving you name A, B, C, D, E, F, G, H. So A was cancelled by E, B was cancelled by F, C का effect was cancelled by G का effect, and D का effect was cancelled by H का effect, and we were left with one extra positive charge. So I said that this whole element, this whole atom is positively charged. ठीक? First I can do this. Or the second thing what I can do is, I can decrease a negative charge. ठीक है? एक नेगेटिव कम कर दिया तो ए और ई कैंसिल हो गए, बी एफ कैंसिल हो गए, सी जी कैंसिल हो गए, डी इज लेफ्ट. Then also this overall atom is positive charge, right? So there are 2 ways for an element, yeah, for an atom to get positive charge. Acha, which one is easy? Second one is easy. Electron को निकालना is easy rather than introducing a positive charge. Why? Because जो protons हैं, if I'm saying this big element, अभी हमने बात किया ना, एक element एक बड़ा सा क्रिकेट का फील्ड है एंड द न्यूक्लियस इज अ क्रिकेट बॉल वेरी डीप इनसाइड द फील्ड. तो अगर हमें पॉजिटिव चार्ज देना होगा, सो आई हैव टू गिव द पॉजिटिव चार्ज ऑन दिस क्रिकेट बॉल ओनली. आई कांट गिव द पॉजिटिव चार्ज ऑन द ऑर्बिट्स, क्योंकि ऑर्बिट्स में तो इलेक्ट्रॉन है, राइट? So it is very difficult in a very big thing. It is very difficult to introduce something in the middle, right?
Yes.
तो इसीलिए giving positive charge to an atom is very difficult. So in order for any atom to get a positive charge, what we do is we decrease the number of electrons. ठीक है? Why? Because electrons are on the superficial. वो ऑर्बिट्स में होते हैं, वहां से इलेक्ट्रॉन निकालना इजी होता है. इसी तरह से सेम वे, इफ आई वांट टू मेक एनी एलिमेंट negatively charged, so I can do by 2 ways. ठीक, I have to make it negatively charged, so I can do it by 2 ways. कैसे? Either I can I can decrease the positive charge or I can increase the negative charge. ठीक है? अब इफ आई वांट टू डिक्रीज द पॉजिटिव चार्ज, तो सेम वही काम करना पड़ेगा, डीप इनसाइड द न्यूक्लियस से हमें पॉजिटिव चार्ज निकालना पड़ेगा, विच विल बी वेरी डिफिकल्ट। व्हाई? बिकॉज इलेक्ट्रॉन्स जो हैं वो प्रोटॉन्स पे एक अट्रैक्टिव फोर्स लगा रहे हैं हमेशा, so it will be very difficult for us to take out the proton from the nucleus. So what we do, हम क्या करते हैं, हम लोग एक इलेक्ट्रॉन एक्स्ट्रा दे देते हैं, we give an electron extra, so this effect is cancelled by this, and since we have an extra minus charge, तो overall charge जो आता है किसी element पे, that comes out to be negative. ठीक है, so अगर अगर if I have to make calcium positive, so what I'll do is I'll decrease the number of electron. ठीक है, तो अभी जो अभी अभी if I'm saying कि I have to calcium यहाँ बताया था मैंने आपको, ठीक है, कैल्शियम 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 कहाँ बताया ये calcium. So if I'm saying, if I was talking about calcium neutral atom, I can't hear you if you are saying something.
No, ma'am.
Okay. So if I'm talking about calcium, if I'm talking about calcium plus, so what I'll say is a calcium plus के लिए I have decreased the number of electrons. So in calcium positive, there will be 19 electrons, 20 protons and 20 neutrons. Neutrons पे कोई फर्क नहीं पड़ेगा, ठीक है? And if I'm talking about chlorine negative, so chlorine negative में what I have done, I have increased the number of electrons. So now there are 17 protons and 18 electrons. तो mass पे तो कोई फर्क नहीं पड़ेगा because electron doesn't contribute to the mass, right? So what is happening is कि the overall charge, overall atom becomes negatively charged, mass उसका same रहता है, बस number of electrons increases. Why I have told you these things? Because question ऐसे भी आएंगे कि it will give you something like, for example, it will give you Na plus. ठीक है, Na plus कह देगा atomic number is 11 and atomic mass is 23. Now find out the number of protons, neutrons, electrons and nucleons. Can you find out now?
Yes.
Try to find out and tell me the answer.
Proton is 12 and neutrons is also 12. Electron is 11 and nucleus is 23.
If you are saying that number of protons are 12, so how can be the atomic number 11? Because atomic number is constituted by protons only. तो गलत हो गया, यही तो ट्रिक है. See what is happening. If we are saying that this atom is positively charged, it means we have decreased the number of electrons. We can only increase or decrease the proton. We cannot change the number of protons. ठीक है, सिर्फ इलेक्ट्रॉन को हम चेंज कर सकते हैं, हम प्रोटॉन को चेंज नहीं कर सकते. तो प्रोटॉन विल बी 11 ओनली, द इलेक्ट्रॉन्स विल बिकम 10.
Okay, ma'am.
Okay, now again one more question. Now tell me the number of electrons, protons, neutrons, and see, एक trick बताते हैं. Whenever you have been asked about protons, neutrons, and all these things, सबसे पहले see the atomic number. Whatever is the atomic number is the number of protons. सबसे पहले ये आंसर दो. And whatever is the mass number, that is neutrons. Because you will be given with the atomic mass and atomic number. तो atomic mass atomic number दिया है तो protons और neutrons को लिख के साइड करो. ठीक है. उसके बाद electrons और neutrons अपने आप तुम्हें समझ में आ जाएगा. Try this trick, then see if you are able to do it or not.
Okay. Number of protons is 7.
Protons is 7. Very good.
And neutron is also 7. Electron is 8 and neutrons is 14.
Very good. So was that easy with the trick to find out?
Yes, ma'am.
Yes. So always follow that trick. So I think now you are clear with the atomic number, atomic mass, and all these things. ऐसा कोई question आता है, so you'll be able to do it, right?
Yes.
Okay. अच्छा, if I'm saying एक इसी का उल्टा question I'm giving you. If I'm saying that I have an element and I'm giving electrons, protons, and neutrons का number, and I'm telling you to find out the name of that element. ठीक है? Don't worry, I'll give between 1 to 20 only. Uh, okay, I'm saying the number of electrons are 16. The number of electrons are 18, the number of protons are 16, and the number of neutrons are 16 only. Now tell me which this species is, which element I'm talking about, and write it in a proper notation. This form. What form? This जो मैंने आपको बताया था ना, x वाला form. X A Z. Sorry, Z A. Write the species in the form of this. Tell me the value of A, tell me the value of Z, and tell me the value of X. Okay? And also
Okay.
if it has any charge or anything.
atomic number is 16, atomic mass is 32, and charge is 2 minus.
What is that element? Atomic number 16 किसका है? It is sulfur.
Okay.
Okay. So after this, I think we are clear with the concept of atomic mass as atomic number. ऐसा कोई भी question आएगा तो I'm sure now you will be able to do it. ठीक है? Either it is of charge, positive charge or negative charge, right? Are you confident with that?
Yes, ma'am.
Okay. Now let us move to the drawbacks of Rutherford model. Okay. What were the drawbacks of Rutherford? Now, Rutherford said that he maintained a similarity between solar system and uh, the atom. Okay. Okay. Now, in solar system we don't have charge, right? Solar system में we have mass, and उस mass पे gravitational force act करती है, so that जो वो है planets हैं वो move कर रहे होते हैं, right? कौन सी gravitational force act करती है? G m1 m2 upon r square. ठीक है, तो उसी के एनालॉजी में ही सेड कि जो हमारे पास एटम है उस पे फोर्स ऐड कर रहा है F K Q1 Q2 upon R square, right? He said that. ठीक, and what is this force? This is electrostatic force which you will study in class 12 chapter number 1 physics. ठीक, it is a force, दो चार्ज पार्टिकल अगर किसी डिस्टेंस पे रखे हुए हैं, so this force acts between them. ठीक, अच्छा, now ये तो ठीक है, बट मैक्सवेल की एक थ्योरी है. Can't see my screen.
Yes, ma'am.
Can you see my screen?
Yes.
Okay, because I can't see it. Okay, now Maxwell की एक theory है, क्या theory है कि Maxwell says that if any charge particle is in acceleration, एक minute. Now, what is the Maxwell's theory? The Maxwell's theory is that if any charged particle is in acceleration, तो उस पे क्या होता है? एक attractive force लगता है. ठीक है? कैसे? अच्छा, now you'll say कि atoms are in circular motion. Circular motion में तो speed constant है, तो acceleration कैसे हो रहा है? Acceleration is a vector quantity, right? तो स्पीड के साथ साथ उसका डायरेक्शन हर पॉइंट पे चेंज हो रहा है, राइट? सी, इफ आई एम सेइंग दैट दिस इज अ सर्कुलर मोशन, कोई इलेक्ट्रॉन इज डूइंग अ सर्कुलर मोशन, तो उसकी स्पीड इज कांस्टेंट बट इट्स डायरेक्शन इज एवरी टाइम, उसका डायरेक्शन सी इट इज चेंजिंग, राइट? And since its direction is changing, so the element, the object that is in circular motion, उसके पास acceleration आ गया. ठीक, now according to Maxwell की theory है कि charge particle when they are accelerated they emit electromagnetic radiation. ठीक, what is the Maxwell's theory? Maxwell's theory is that when any charged particle is accelerated they emit radiation. तो do we if I see, तो अब ऐसा अगर ये ट्रू है, मैक्सवेल की थ्योरी तो प्रूवन है, और अगर रदरफोर्ड की बात ट्रू है कि वो एलिमेंट जो है वो सर्कुलर मोशन कर रहा है ऑर्बिट में, इलेक्ट्रॉन सर्कुलर मोशन कर रहा है ऑर्बिट में, सो एलिमेंट्स तो ग्लो करने चाहिए, उसमें से कोई रेडिएशन निकलनी चाहिए, बट कोई रेडिएशन देखी नहीं गई. तो एक तो ये कॉन्ट्रडिक्ट कर रही थी रदरफोर्ड की बात. दूसरी बात क्या थी? दूसरी बात ये भी है कि बात क्या थी? हाँ, दूसरी बात ये थी कि एक ऐसा टाइम आएगा कि जब सिंस जो न्यूट्रॉन्स हैं वो इलेक्ट्रॉन्स के साथ इलेक्ट्रोस्टैटिक फोर्स कर रहे हैं, ठीक है। न्यूट्रॉन्स जो है, सॉरी द प्रोटॉन्स जो है वो इलेक्ट्रॉन्स के साथ इलेक्ट्रोस्टैटिक अट्रैक्शन में है, राइट। सो व्हाट इलेक्ट्रॉन्स विल डू, इलेक्ट्रॉन्स विल सॉरी प्रोटॉन्स विल अट्रैक्ट द न्यूक्लियस। प्रोटॉन्स जो है वो इलेक्ट्रॉन्स को अपनी तरफ अट्रैक्ट करेंगे, राइट। तो एक पॉइंट ऐसा आएगा कि ऑल द इलेक्ट्रॉन्स विल बी अट्रैक्टेड टुवर्ड्स द न्यूक्लियस एंड द एटम विल कोलैप्स, लेकिन ऐसा कुछ तो हो नहीं रहा है। तो ये दो ड्रॉबैक्स थे, क्या कि एक तो रदरफोर्ड का मॉडल जो था वो मैक्सवेल थ्योरी को नहीं एक्सप्लेन कर पा रहा था। मैक्सवेल थ्योरी वाज प्रूवन ऑलरेडी, ठीक है। मैक्सवेल थ्योरी के प्रूव होने के काफी दिन बाद ये थ्योरी आई थी, और दिस थ्योरी डिड नॉट was not able to go with that Maxwell's theory, ठीक। पहली बात तो ये, और दूसरा बात ये कि जो मेटल को कोलैप्स होने वाली थ्योरी थी, दैट आल्सो रदरफोर्ड वाज नॉट एबल टू explain. So that's why these were the two contradictions which led to failure of Rutherford's model, ठीक है।
Yes.
Okay, so this was all about Rutherford model. अब हम क्या पढ़ेंगे, अब हम थोड़ा कॉम्प्लेक्स चीजें पढ़ेंगे। अब हम थोड़ा डुअल नेचर की तरफ चलेंगे, ठीक। नेचर क्या, पार्टिकल नेचर एंड वेव नेचर। तो अभी तक जो भी पढ़ा वाज दैट क्लियर, एक बार रिकॉल करो पूरी चीजें शुरू से लेकर के, डिस्कवरी ऑफ इलेक्ट्रॉन से लेकर के अभी तक। इज देयर एनीथिंग, एनी टॉपिक जो तुम्हें समझ में नहीं आया हो, बिकॉज अब जो शुरू होगा इट इज एंटायरली अ न्यू टॉपिक, उसका पिछले टॉपिक से कुछ भी लेना देना नहीं होगा, तो पिछला कुछ भी रिवाइज नहीं होगा। So take a
Yes.
quick view. If there's anything that is a थोड़ा सा भी छोटा सा भी डाउट है अगर किसी टॉपिक में।
No, ma'am. No. That's-
So let us move to the developments which led to the dual nature of electromagnetism. अच्छा, now क्या हुआ, एटम्स का जो रिजल्ट्स, जितने भी रिजल्ट्स वी हैव ऑब्टेन, व्हाट वी हैव डन, वी हैव इंटरैक्टेड एटम्स विद इलेक्ट्रोमैग्नेटिक रेडिएशन, ठीक है। जिसकी वजह से वी गॉट मेनी इंफॉर्मेशन अबाउट एटम्स एंड मॉलिक्यूल्स, ठीक है। now what did Niels Bohr do, he utilized all the results, ठीक है, and improved the Rutherford's model. What did he say, he said that he like uh, what did he say, he formulated the model. How did he formulate his model? By using the results from Rutherford. What did he say? He said that dual character of electromagnetic radiation. He formulated that जो electromagnetic radiation है, whatever radiation which we are using, या जो भी light है, electromagnetic radiation कैसे समझाऊं, अभी समझो एक रेडिएशन इज अ टाइप ऑफ एनर्जी, ठीक है। दैट एनर्जी, वॉट एवर वी आर टॉकिंग अबाउट, दैट एनर्जी हैज बोथ वेव लाइक नेचर एंड पार्टिकल लाइक नेचर ऑल्सो, ठीक। what did he say, he said that electromagnetic radiation, जिसकी अभी हम आगे बात करेंगे कि electromagnetic radiation होता क्या है, so that has both nature, wave like and particle like also, ठीक है। Also he gave experimental result of atomic spectra. Atomic spectra क्या है, जो atoms radiation निकाल रहे थे, ठीक है। atoms were radiating something, they were अच्छा क्या निकाल रहे थे, अभी जब we'll study wave nature ना, तो उसमें बताएगा कि what are electromagnetic radiation, that you'll see कि atoms they were radiating something, और उसकी वजह से एक हमें स्पेक्ट्रम मिल रहा था। स्पेक्ट्रम क्या है, डिफरेंट वेवलेंथ्स की एक हमें सीरीज मिल रही थी, दैट वाज स्पेक्ट्रम। तो इन दोनों को बोहर ने एक्सप्लेन किया यूजिंग द रदरफोर्ड मॉडल, बाय द रिजल्ट ऑफ रदरफोर्ड मॉडल, ठीक है। So let us see what is electromagnetic radiation. So the next topic is wave nature of electromagnetic radiation. अच्छा, मिड 19th सेंचुरी में फिजिसिस्ट जो थे, जो फिजिक्स पढ़ रहे थे, दे एक्टिवली स्टडीड अबाउट द एब्जॉर्प्शन एंड इमिशन ऑफ रेडिएशन बाय हीटेड ऑब्जेक्ट। क्या पढ़ रहे थे वो, कि अगर हम कोई ऑब्जेक्ट हीट करते हैं, अभी भी इफ यू हीट एनी ऑब्जेक्ट, यू विल सी कि इट चेंजेस इट्स कलर, राइट? तो कलर चेंज क्या होता है बेसिकली? कलर चेंज इज बेसिकली कि फॉर एग्जांपल इफ आई सी एनी कलर, तो उसमें से कोई रेडिएशन निकल रहा होगा ना, डिफरेंट वेवलेंथ का। जो कलर चेंज हो रहा है, इट इज चेंजिंग वेवलेंथ। फॉर एग्जांपल कि इफ आई एम सीइंग ब्लू, ब्लू कलर, इसका मतलब कि सारे के सारे वेवलेंथ्स आर बीइंग एब्जॉर्ब, ओनली ब्लू वाला इज गिविंग आउट, सो आई कैन सी ब्लू कलर, राइट? तो अभी अभी हमें ये पता है, लेकिन तब ये पता नहीं था। तो फिजिसिस्ट जो थे ये पढ़ रहे थे कि व्हेनेवर वी हीट एन ऑब्जेक्ट, सो व्हाई डू वी सी डिफरेंट कलर्स। ठीक। अब अभी आई टोल्ड यू कि वी नो दैट थर्मल रेडिएशन कंसिस्ट ऑफ इलेक्ट्रोमैग्नेटिक वेव ऑफ डिफरेंट वेवलेंथ सी। थर्मल रेडिएशन क्या होता है? अगर हम कोई ऑब्जेक्ट हीट करते हैं, ठीक, अच्छा, इफ वी गिव एनर्जी टू एनी ऑब्जेक्ट इन द फॉर्म ऑफ हीट, नाउ फॉर एग्जांपल इफ यू हीट एन आयरन रॉड, ठीक है, तो पहले क्या होगा? पहले यू सी दैट इट इज रेड इन कलर, पहले वो रेड कलर में आएगा, फिर थोड़ी देर बाद इट विल कन्वर्ट इनटू व्हाइट कलर, एंड आफ्टर सम टाइम यू सी इट विल कन्वर्ट इनटू ब्लू कलर। इफ यू हैव एवर सीन हीटिंग एन आयरन रॉड, you'll see कि first the iron rod is emitting out red color, then it is emitting out white color, then it is emitting out uh, blue color। ये कैसे हो रहा है ये भी एक्सप्लेन हो। ठीक। अच्छा, ये होता है बेसिकली क्यों? इट इज ड्यू टू चेंज इन फ्रीक्वेंसीज एंड द वेवलेंथ ऑफ द इमिटेड लाइट। अच्छा, क्या है ये? लेट अस सी। The first active thermal radiation laws was done by 1850। How? And the theory of electromagnetic wave and emission of such particle of charged particles। How did it? कि जो charged particle को accelerate करके जो emission मिल रहा था, that was developed by मैक्सवेल। जो अभी हम लोग क्या पढ़ के आए ना कि जो मैक्सवेल की थ्योरी, रदरफोर्ड का मॉडल वाज नॉट एबल टू एक्सप्लेन द मैक्सवेल की थ्योरी कि चार्ज पार्टिकल एक्सेलरेट करेगा तो रेडिएशन देगा। तो दैट एक्सपेरिमेंट वाज डन बाय मैक्सवेल इन 1870s। ठीक है, देयर वर सम फैक्ट्स जो इलेक्ट्रोमैग्नेटिक रेडिएशन से रिलेटेड थे। क्या थे? He said that interaction between the charged bodies, if we have any charged body, for example we have a positive charge or a negative charge, and इस पे we give out electric field or magnetic field। ठीक है, इस पे अगर we give out magnetic field और electric field, तो क्या हो रहा है? तो व्हाट डिड ही गिव? तो इसका रिजल्ट क्या आ रहा है? तो एक पॉजिटिव चार्ज या नेगेटिव चार्ज है हमारे पास, इस पे वी गिव आउट आइदर इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड और बोथ। तो उससे हमें कुछ ट्रांसमिशंस मिल रहे हैं, इससे हमें कुछ एनर्जी रेडिएट करती हुई मिल रही है। दैट एनर्जी वाज कॉल्ड इलेक्ट्रोमैग्नेटिक रेडिएशन। ठीक है, when any charged particle is given electric field or magnetic field, so it gives out some radiations। ठीक है, and those radiations were called as electromagnetic waves or electromagnetic radiation। ठीक है।
Yes.
लाइट इज इन, अच्छा क्या है मैंने पढ़ाया? ठीक है, लाइट इज अ फॉर्म ऑफ रेडिएशन, जो कि सी हमें ये पता है कि लाइट इज अ रेडिएशन, राइट? लाइट लाइट रेडिएट करती है, लाइट एक रेडिएशन है। और न्यूटन के टाइम पे इट वाज वेल एस्टैब्लिश्ड फैक्ट दैट लाइट इज अ वेव। ठीक, न्यूटन के टाइम पे जो क्लासिकल फिजिक्स है, दैट टोल्ड कि लाइट इज अ पार्टिकल नेचर। लाइट का जो नेचर है वो पार्टिकल नेचर है। पार्टिकल नेचर मतलब कि वो टुकड़ों में आती है, इट इज नॉट कंटिन्यूअस। लाइट कम्स इन फॉर्म ऑफ पैकेट्स, टुकड़ों में आती है। बट अभी जब मैक्सवेल ने अपना एक्सपेरिमेंट किया, तो इट वाज एक्सप्लेन कि लाइट के अंदर वेव नेचर भी है। ठीक है, लाइट के अंदर वेव नेचर भी कैसे है? क्योंकि उसके अंदर एक्सीलरेटिंग, उसके अंदर इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड भी है। सी अभी 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 ये व्हाट आई टोल्ड यू, इसको देखो, थोड़ा सा कंफ्यूजन है। कंफ्यूजन क्या है? ये जो मैक्सवेल का थ्योरी, मैक्सवेल का एक्सपेरिमेंट आई एक्सप्लेन यू, इट इज अ डिफरेंट, अभी डिफरेंट। क्या है? वी हैव अ चार्ज, ठीक है, वी हैव अ चार्ज बॉडी, इसको आई एक्सीलरेटेड, इसको मैंने कोई एक्सीलरेशन दिया। सो जब मैंने इसको एक्सीलरेशन दिया है, तो इट विल प्रोड्यूस इलेक्ट्रिकल फील्ड एंड मैग्नेटिक फील्ड। अभी जो मैंने बोला उसका उल्टा बता दिया था। तो एक चार्ज पार्टिकल है, उसको आई गेव एक्सेलरेशन, तो ये क्या प्रोड्यूस करेगा, इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड। और कैसी फील्ड होंगी, ये जो इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड है, दे आर परपेंडिकुलर ईच अदर, ठीक है। तो अभी मैंने कल आपको एक्सप्लेन किया था ना कि इफ दैट इलेक्ट्रिकल, इफ नहीं आपको नहीं एक्सप्लेन किया, if that charge is moving in x direction, so electrical field will be produced in y direction and magnetic field will be produced in z direction. So all the movement of electron, the acceleration of electron, the produced magnetic field and the produced electrical field, all will be perpendicular to each other. ये था मैक्सवेल का एक्सपेरिमेंट। और ये जो इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड निकल रही है, इसी को रेडिएशन कहा गया, ठीक है। और इसी को मैक्सवेल ने प्रूव किया कि जो हमारी लाइट है उसके अंदर भी इलेक्ट्रिकल और मैग्नेटिक कैरेक्टर है एंड दे आर ऑक्सीलेटिंग, कंटिन्यूअसली ऑसिलेटिंग, ठीक है। सो इट हैज अ वेव नेचर। सो मैक्सवेल ने न्यूटन ने प्रूव किया था कि लाइट हैज पार्टिकल नेचर, एंड मैक्सवेल ने प्रूव कर दिया कि light has wave nature also, ठीक। and why are we studying this here, because अभी we will see कि जो हमारा एटम है ना, उससे भी electromagnetic radiations निकल रही है, it is giving out spectrum. So before reading the spectrum we must know कि what are electromagnetic radiation, so that's why we are studying electromagnetic radiation, ठीक है। अच्छा, see electromagnetic जो wave motion है, it is very complex, so we'll only see some properties of it, ठीक है। तो पहली प्रॉपर्टी जो हम देखेंगे इलेक्ट्रोमैग्नेटिक रेडिएशन की, वो ये है कि इट हैज इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड विच आर ऑसिलेटिंग परपेंडिकुलर टू ईच अदर। तो इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड जो है वो एक दूसरे के साथ परपेंडिकुलर डायरेक्शन में एक्सेलरेट कर रही हैं, और उसके साथ साथ जो इलेक्ट्रॉन है वो एक्सेलरेट कर रहा है, इसका जो चार्ज बॉडी है वो एक्सेलरेट कर रही है, इसका मतलब वो भी मूव कर रही है। तो तीनों एक दूसरे के म्यूचुअली परपेंडिकुलर है, तीनों तीन डायरेक्शन में मूव करेंगे एंड इन सच अ वे दैट ऑल द थ्री आर म्यूचुअली परपेंडिकुलर। तो दिस इज द फर्स्ट प्रॉपर्टी ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन, ठीक है। अच्छा, दूसरी प्रॉपर्टी क्या है कि जो भी हमारा इलेक्ट्रोमैग्नेटिक रेडिएशन है, इट डज नॉट नीड एनी मीडियम टू ट्रेवल, इट कैन इजीली ट्रेवल विदाउट एनी मीडियम, ठीक है। फॉर एग्जांपल जैसे लाइट है, लाइट इज आल्सो अ रेडिएशन, सो वी कैन सी कि लाइट कैन ट्रेवल विदाउट एनी मीडियम, स्पेस से लाइट हमारे पास आ रही है, सनलाइट, इसका मतलब इट डज नॉट नीड एनी मीडियम टू ट्रेवल। अनलाइक साउंड, साउंड को मीडियम चाहिए होता है, ठीक। नाउ द थर्ड प्रॉपर्टी इज दैट कि जो इलेक्ट्रोमैग्नेटिक रेडिएशन है उसमें देयर इज डिफरेंस इन वेवलेंथ एंड फ्रीक्वेंसी। जो हमारा इलेक्ट्रोमैग्नेटिक रेडिएशन है ना, उसमें डिफरेंट डिफरेंट इंटरवल्स पे फ्रीक्वेंसी और वेवलेंथ में डिफरेंसेस आते हैं, एंड ड्यू टू दैट डिफरेंसेस वी गेट अ स्पेक्ट्रम दैट इज कॉल्ड इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम, ठीक है। तीसरी property is that कि whatever radiation we see, it has different frequencies and wavelength at different interval, and due to this different frequencies and intervals we have electromagnetic spectrum. Got it?
Yes, ma'am.
Okay, and what is that spectrum? Abhi I'll draw that. What is the fourth property? Fourth property is that we have different units to represent these electromagnetic radiation. अब वो क्या है? वो different units, angstrom, nanometer, ये सब होती है. Let me draw the electromagnetic spectra for you. ऐसा एक बॉक्स होगा and it will start from ऊपर I am writing the frequencies. Okay, एक give me. Yes. So ऊपर I'm writing frequency and नीचे I'll write wavelength. So the frequency is starting from 10 raised to the power 24 and it is ending at 1. 10 raised to the power 0 that is 1. ठीक है? And the wavelength is starting at 10 raised to the power minus 16 and it will end at 10 raised to the power 8. ठीक है? We have different frequencies. Now what I'll do is I'll make differences. यहाँ पे ठीक. Now if I'm saying कि 10 raised to the power minus 24 से 10 raised to the power minus 10 is about 20 that I'm going. ठीक है? Not this is not minus 24, it is 24. So this region comprises the gamma rays. तो जिस भी फ्रीक्वेंसी जिस भी इलेक्ट्रोमैग्नेटिक रेडिएशन की रेंज किसकी रेंज फ्रीक्वेंसी की रेंज 10 इज अबाउट 24 से 10 इज अबाउट 20 के बीच में लाई करेगी आई विल कॉल इट गामा रेज ठीक है उसके बाद कम्स एक्स रेज की फ्रीक्वेंसी कहां तक लाई करेगी इट विल लाई टू द 10 इज अबाउट 17 देन वी हैव यूवी रेज और इसी बीच में वी हैव विजिबल रेज टू 10 raised to the power 17 से I think it is 10 raised to the power 15 तक we have UV rays और इसी में that is visible region जो हम लोग देख सकते हैं ठीक है it ranges from 400 to 750 ठीक है that is the wavelength yes it is the wavelength it is not the frequency it is wavelength तो visible region जो लाइट हम लोग देख पाते हैं ना व्हाइट लाइट वो ये है इसी इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम का एक पार्ट है right okay then we have infrared जिसकी frequency is 10 raised to the power 11 then we have microwave जिसकी frequency is 10 raised to the power 9 then we have radio waves जिसकी frequency is 10 raised to the power 5 and then we have long radio wave which lies between 10 raised to the power 5 to whatever the ठीक है this is the electromagnetic spectrum I have not mentioned the wavelength but you must learn this इसकी wavelength आपको याद होनी चाहिए questions आ सकते हैं ठीक so based on the difference is frequencies and wavelength we have got a spectrum and that spectrum is called as electromagnetic spectrum ठीक है
Yes.
okay now I'm talking about frequency and wavelength. So what are these? So frequency is basically frequency. Frequency is basically yes. If I'm saying that I have taken a point, so and I have said that 8 seconds. Whatever the number of waves that are passing from this point in 1 second, that is the frequency of that wave. So what is wave? What is frequency? Frequency is the number of waves that pass through a given point in 1 second. And what is the SI unit of frequency? The frequency, it is represented by this sign and it has the SI unit as Hertz, which is given by the name scientist Heinrich Hertz. Heinrich Hertz के नाम पे frequency has given the unit Hertz. Hertz is basically second inverse. Second inverse को ही Hertz कहते हैं. Right? So frequency समझ में आ गया frequency is what the number of waves that pass through a particular point in 1 second ठीक अच्छा दूसरा टर्म हमने क्या पढ़ा दूसरा टर्म इज द वेवलेंथ क्या है वेवलेंथ इज बेसिकली द लेंथ ऑफ द वेव एक अप और एक डाउन का whatever the length that will be it is called as the wavelength and is measured in meter ठीक है
Yes.
these were the two properties of the wave that we should know अच्छा तीसरी चीज क्या है तीसरी चीज is that कि all the waves be it radio waves be it microwaves anything ठीक है anything if I say कि I'm saying that these waves are moving in vacuum so it will have the value of speed as 3 into 10 raised to the power 8 कोई भी wave हो if it is traveling in vacuum तो उसकी speed will be this only which is called the speed of light. Now we have a relation which relates the speed, wavelength, and frequency of the electromagnetic radiation. That is speed को if we represent by c, so c is equals to lambda mu, या lambda v, ठीक? Where c is the speed of light, that is 3 into 10 raised to power 8 in most of the cases. Lambda is the wavelength, and this is the frequency of the given wave, given electromagnetic spectrum. Okay, given wave. Okay.
Okay.
Now we also have a term named as wave number. तो wave number क्या होता है? Wave number, which is generally represented by k or this mu dash, that is 1 upon lambda. हम क्या करेंगे? वेवलेंथ का रेसिप्रोकल ले लेंगे, that is wave number. Okay.
Ma'am, can you
There is a term named as wave number. Okay, what is wave number? Wave number, which is represented by sometimes k or by mu dash, it is just nothing but the reciprocal of wavelength. That you have to divide the wavelength by 1 by wavelength. That is, you can't hear me? एक minute. Let me connect the Wi-Fi again. Yes, can you hear me now?
Yes, ma'am.
Yes. So what is wave number? Wave number is nothing. You just have to got it.
Yes, ma'am.
Okay. Now after this thing, we have a question. Let us solve this question. In this question, what it's saying, the question is saying that Vivid Bharati station of All India Radio, it has the frequency of 1368 kilohertz, and we have to calculate the wavelength of this radiation, and we also have to tell EM spectrum में, electromagnetic spectrum में, to which region this wave belongs. ठीक है, तो हम wavelength निकालेंगे and then we'll see the electromagnetic spectrum and we'll judge कि ये किसमें lie करता है. अच्छा, do we have any relation between wavelength and frequency? Yes, we have a relation, that is C is equals to F lambda, right?
Yes.
C की स्पीड अगर आपको क्वेश्चन में नहीं दी हुई है तो assume that it is talking about that it is talking in vacuum. So we'll take 3 into 10 raised to the power 8. Then we have frequency as 1368. It is in kilohertz. We'll convert it into hertz. It will be 10 raised to the power 3 into lambda. So lambda will be 3 into 10 raised to the power 8 divided by 1368 into 10 raised to the power 3. Okay, it will come out to be, if you do the calculation, ये 3 5, and if we divide 3 by 1368, it will come out to be divided by, I mean 1929 into 10 raised to the power 5. ठीक है, so what can I say? इसको if I move the 1 2 3 4 5, I can say 219.29 meter. So the wavelength came out to be 219.29 229 meter, or I can say 219.3 meters. Now see, if you have your LCRT, open the electromagnetic spectrum and see कि 219 किस region में belong करता है. I think 219 जो belong करेगा, it will belong to 10 raised to the power 0 से लेकर के 10 raised to the power 3 के बीच में आएगा, right? Like 1 से 1000 के बीच में आएगा, right? And what is the wavelength between 1 to 1000? इसके बीच में lie कर रहा है. It is अच्छा. You cannot judge like this. I'm sharing the screen. You'll be able to see. See, if you can see this if you can see ये 10 raised to the power 0 and 10 raised to the power 1. See, if you can see this thing, 10 raised to the power 0 से 10 raised to the power 3 आएगा ना यहाँ पे. 10 raised to the power 0 से 10 raised to the power 3 के बीच में, यानी 10 raised to the power 0 is 1 and 10 raised to the power 3 is 1000. So wavelength, किस wavelength, and 293 will lie in this region only, right? इसी region में तो आएगा 293. So the wavelength which we found out will be the radio wave. Okay? Why radio wave? Because the value came out to be 293 point, yeah, what they came out to be. Came out to be 219.3. ठीक है? Clear? How did we see the value of wavelength and how did we find out the value of wavelength? कैसे हमने इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम से अपनी फाइंड की हुई वेवलेंथ को कंपेयर किया? Did you got this? Okay. So I think we are clear with electromagnetic radiation. We are clear with Rutherford model, and we are also clear with the electromagnetic radiation, right? Yeah. Yes. So are we clear with all the topics we have studied today? Okay. If you have any problem, acha, do you try the homework? You said that you will do it by today. Did you try the homework? I can't hear you. Please write in the chat box. If you didn't try it, try it. And if you get any problem in the homework, you can ask me in the next class. Okay. After whatever is left in this chapter, we'll continue in the next class. Okay. Okay, Homer, I can't hear you. But whatever you are saying, you can type in the chat box.